All right, so let's go ahead and take a look at this next example in this case, guys, and we're focused on simplifying the expression. I have an x squared minus an x squared minus a 4 over an x minus a 2 equals a 4 in this case, all right? Now, when we finish solving for this, guys, we are going to be coming back to this because we do have a variable in the denominator. So in this case, when we find our value, we have to look in this case for what number x cannot be. Because if we have a certain x value, the denominator could be 0 and create an undefined solution. So I'm sure you guys could probably tell what number is going to be, but we'll come back and check. So in this case, I want to go ahead and solve for or simplify the expression here. So I do want to go ahead and get rid of my fractions. So what we're going to do in this case, guys, is we're actually going to multiply everything by the denominator, which is x minus a 2. So I'm going to go ahead and multiply this here by x minus a 2. Multiply this here by x minus a 2. And multiply the 4 as well by x minus a 2. In this case, by doing so, I am actually eliminating this one here. And then I have our following expression. I have an x squared. I have an x squared times x minus a 2 minus an x squared minus a 4 equals a 4 times an x minus a 2. All right. So then distributing, let's go ahead and say let's multiply that out. Let's go ahead and distribute. That gives us x cubed minus a 2x squared. Then let's go ahead and distribute this one here. So that's a negative x squared minus plus a 4 equals, distributing once again, 4x minus 8. All right, this is what we have. Now, let's go ahead and move everything to one side. So I'm actually going to subtract the 4x. Subtract the 4x. Well, actually, before we do that, let me combine like terms first, and then we can move things around. So I could actually combine these two, which is going to give me x cubed minus a 3x squared plus a 4 equals a 4x minus 8. Now from here, let's go ahead and move things around. Let's go ahead and subtract 4x, subtract 4x, so add an 8, and add an 8, so that cancels. In this case, the negative 4x can't really be combined with anything, so we'll just be rewriting them as follows. Squared minus a 4x plus 12 equals a 0. Now, on this one here, guys, this one seems a bit different. In this case, my highest exponent is a 3, which means I really can't do the diamond method on this one. I can't factor or use it. I actually have to use a different type of factoring. Now, I'm not sure if you guys recall grouping. Does that ring a bell for you guys? Grouping, factoring by grouping. Or in this case, we were focused on grouping 4 terms. In this case, we were going to group the first 2 terms and the last 2 terms in this case and work on from there. So let's go ahead and do that. Let's go ahead and do grouping. So first off in this case, guys, is what's the GCF of the first binomial? What can I factor out from both of these expressions? Answer for that is an x squared. Now let's go ahead and take a look at the next one. What can I factor out from this one? That's the GCF. And I do have a negative 4x plus 3. GCF for both of those is actually a negative 4 because the leading coefficient is negative. So let's go ahead and rewrite that. I have a 3x in front, or actually x squared, open parentheses. If I factor out an x squared from an x cubed, I have x. And if I factor an x squared from negative 3x, I have a negative 3. All right, that's the first one. Now, minus 4, open parentheses. If I factor out a negative 4 from negative 4x, I have x. And if I factor out a negative 4 from 12, I have a negative 3. Notice in this case, guys, we actually now have something in common, right? They have in common, this expression here. So factoring by group in this case is like basically taking a third GCF out, which is the expression of x minus a 3. And then the other binomial in this case is composed of what was taken, the first GCFs in this case, which is x squared and then negative 4. And all of that is equal to 0. So in this case, guys, we're focused on solving for x. Hopefully I didn't lose anybody on this process here, but once again, that is grouping. Because I had 4 terms in this case, the highest one was a 3. I couldn't do the diamond method, but I could do something else. So let's go ahead and see this here. Let's make each of the binomials in this case equal to 0. X minus 3 equals 0. And x squared minus 4 equals 0. So I'm going to go ahead and first add 3 to both sides. And in this case, x is going to equal positive 3. And then on this one, let's go ahead and add 4 to both sides. And I know some of you might have been thinking, oh, diamond method. We could have done the diamond method here too. But trying a different route. Square roots. If I want to go ahead and get rid of that squared, I need to do the opposite, which is take the square root. So we'll take the square root on both sides. That gives us x in this case equal to a positive or negative 2. All right. Now, positive or negative 2, guys, it means that x is going to equal x is going to equal a positive 2 and x is going to equal a negative 2. All right. Now, before we say, yeah, we're done, we still need to check, guys. Check which of all of these are a solution, because they could all be a solution. Maybe some don't work. So I have x equals 3. Back up here. X equals 3. X equals 2. And x equals negative 2. So let me actually just erase this. This was our original equation. Now, I have to check with the denominator which value is going to make that a 0. If I input in the 3 there, that's actually going to be a 1. I'm good with that one, so that one's good. We're good with that one. If I put in the 2 here, however, 2 minus 2 is a 0, which gives me a 0 in the denominator, so that can't work. What about a negative 2? Negative 2 minus 2 is negative 4, so that works. So in this case, the solutions for this equation are x equals 3 and x equals a negative 2. So once again, our check is substituting values of x to obtain solution. All right, so we have to do substituting values to obtain a solution. Or we could say in this case, check for value that makes denominator equal to 0. And that would not be a solution. So if we check for that, if number that makes the denominator equal to 0, then that would not be a solution. So that is not a solution.